Alright folks, just 20 seconds of context before we start this episode. This is episode 3 of 5 with Andy Lubershane on fusion level bets. In other words, technologies that could completely reshape the way we think about energy on this planet. In today's episode, we'll talk about crazy cheap renewables. I know it might come as a surprise, but maybe in a world where solar and wind becomes even cheaper than what it is today, it could be considered a fusion level bet. Enough about me talking, let's jump in with Andy Lubershane from Energy Impact Partners on Fusion Level Bets Episode 3, Crazy Cheap Renewables. Well, Andy, we're back again. Very excited for today. Look, let's start with this. Wind and solar both exist since the 1950s, at least in their modern form factor, probably much longer than that. We've been using wind and solar for other things before. What has changed in the last decades that could potentially make it a fusion level bet?
The last 20 years have been this incredible time for wind and solar technology. They've really been two of the biggest success stories of the energy transition so far, along with lithium-ion batteries. And as you say, it's not because of some technology breakthrough that happened in the early 2000s. It's because we took existing technology, the foundations of which, and I think for wind power, were coming from, at least like the 1600s in Denmark, the sort of triple-bladed horizontal axis wind turbine. I'm probably getting the history wrong there, but it's old school, right? And basically taking those technology foundations and scaling them up. I mean, that's really what happened from around 2005 for wind, around 2010 for solar, up until the present day. And a lot of that initially was driven by government policy. So, subsidies, incentives of various types had an enormous role to play. Shout out to Germany in the early days, especially, I think, for solar subsidies, wind as well. California played a really important role. And then, China, when it comes to both deployment of wind and solar, and then the supply chain, which I'm sure we'll talk about, has been very important for solar as well. And so, the cost curves for wind, and in particular for solar, in the past 15, 20 years have been incredible. And these are some of the fundamental building blocks of the energy transition already today. And even if we don't have a fusion level breakthrough, I anticipate that there'll be important building blocks for many decades to come. The question is there a fusion level breakthrough that would make them much more important resources and would help us overcome some of the obstacles to deploying solar and wind?
Okay, so the cost curve is quite amazing so far. We don't know if it's going to be a fusion level bet or not, at least yet. What needs to happen in order for solar, particularly when we think about the cost curve, to qualify this potentially as a fusion level bet?
Yeah, so if you think about where solar costs are today, in many parts of the world, solar is already quite an attractive energy resource, and is getting close to competitive with the marginal cost of the sort of lowest cost of marginal power generation from fossil fuel. In the United States, that's generally natural gas these days, coal at existing power plants, in many parts of the world as well. But in most countries, solar is not quite there. Wind is not quite there either. On a levelized cost of energy basis, building a new power plant, if all you're considering is the levelized cost of energy coming out of that plant, wind and solar are already the cheapest resources in many parts of the world. But of course, LCOE to LCOE is not really a great apples to apples comparison for renewables versus fossil fuel power generation, because fossil fuel power generation is providing all these other services to the grid, peak capacity, firm power supply, inertial response, et cetera, that wind and solar don't inherently provide. So I like to think about the comparison as being the LCOE, the levelized cost of energy from solar and wind versus basically the marginal burn or fuel cost plus a little bit of variable O&M costs for fossil fuel. Obviously, it's not a perfect comparison either. There's a lot of nuance when it comes to power system modeling and how you make these economic comparisons. But that's where I think solar and wind need to get, is to the point where pretty much on every continent, wherever you have pretty good solar and wind resources, open space to build on, and transmission capacity to connect those resources into the power grid, we want solar and wind to be reasonably competitive, if not very competitive, with the marginal cost of fossil fuel power generation. That's like the ideal scenario. That's the prize. And in particular, it's a prize for solar because solar just is more, the resource is more abundant, less geographically constrained than it is for wind, all over the world. Like, except for Antarctica, there are places on every continent where there are good enough solar resources that with the right technology, you could really imagine solar being, it's never going to be the only contributor to primary energy, but a major contributor to humanity's primary energy supply.
Do you believe in a world where basically you have only solar panels and batteries? Like, could that happen?
I mean, anything's technically viable, I suppose. I personally believe that would end up being a way, way, way more expensive energy system than using a more diverse group of resources. I mean, my view is solar over the long term has the potential to be the lowest cost primary energy resource on Earth in certain places at certain times. And in fact, the lowest cost solar that we're seeing in the world today is already in contention for being some of the lowest cost primary energy on Earth. Last year in Saudi Arabia, they signed a number of large power purchase agreements for gigawatts of solar at just these wildly low prices, even without subsidies, $10, $15 a megawatt hour, which, certainly puts you competitive with the marginal cost of coal or natural gas power generation. It's getting to the point where you're approaching the embodied energy value or cost of natural gas or coal, the thermal energy cost of those resources, which is wild. And so again, I think if we're able to get one more big unlock, one more step change in solar costs, then it could be this incredible resource we can tap in many parts of the world where you have really strong natural solar energy available. However, again, like in order to rely on that entirely requires an enormous amount of grid infrastructure, storage infrastructure, which adds more and more cost the more energy you want to source from solar. And so there's a equilibrium point I'm sure we'll find at some point where you try to tap as much low-cost solar as you can before the additional costs of storage and infrastructure and various other constraints start to become a problem.
We will, of course, talk about storage in another episode. It is critical for that transition and for the use of solar and wind, but we're not going to cover it today because it's just like too long of a topic just to talk about it.
Yes.
When thinking about solar, there's one thing that I'd love you to talk about is the difference in terms of the performance and financing of solar versus kind of more fossil fuel based projects. So, solar is quite sensitive to the cost of capital. We've been building projects that quite underperform. Like, what are some of those things that, are the key drivers that can affect the deployment of solar today?
Yeah, I think the biggest drivers, in my opinion, the biggest, while we're on the topic of kind of civilization level technology questions, the big picture challenges for solar are, as you mentioned, number one, it's capital intensive. It's probably the most CapEx intensive form of power generation, which is actually a sort of a backhanded compliment for solar because the OpEx is so low. There's no fuel cost and maintenance is low compared to just about any other form of energy supply. But the CapEx is high, which means that financing costs are high, and small changes in the cost of capital affect solar more than they do, any other form of energy supply. And that's been a challenge, really in the past few years. If you think about that period we talked about at the outset when solar grew up, when from basically 2010 to 2020, which was this magical period of deployment scaling up into the gigawatts and terawatts now for solar, and costs really coming down. Like almost that entire period was this magical time in financial history when we, for the most part, had a zero interest rate policy from the U.S. government, very low cost of capital all over the world. And so, yeah, solar and wind have been challenged by the increase back to even sort of semi-regular levels of cost of capital that we've seen recently. The other big picture challenge for solar, I would say, it's really twofold. One is land use. Solar and wind are both non-power dense resources. They take up a lot of space. That's one of the most obvious things about them when you just look at the resource. And frankly, solar in particular, because you really can't use that land for almost anything else. There's like the possibility of small amounts of light, agrivoltaics, as they say, but like for really truly large scale utility solar installations, you're consuming the land. And while, you could theoretically power the world with, a few hundred square miles of land, doesn't actually consume that much land in the scheme of the earth, because you're building it still hopefully relatively near population centers, you have to find access to transmission. Like the impact on land use is significant and can be a barrier. And then relatedly, transmission access is the other barrier. Because solar is produced in the form of electricity, generally speaking, you're going to want to get it into a power grid as a means of delivering it to consumers all over the place. And the more solar we build, the more land we need, the more you're going to need to look farther and farther from those population centers, which means farther and farther from the existing transmission grid, which means more grid constraints, which means you need to build more transmission to access the solar. And that's kind of this fundamental challenge for solar in general that kind of no amount of technology can really overcome.
And, that's why I love some of the startups projects around helping, for example, supermarkets put it on the parking lots or like places where it's not competing with agricultural purposes, which I find very smart because you can cover your car. You don't need to have sun on your car while you're parking and, doing your grocery shopping or whatever. But coming out of all of those things that you've mentioned, so the cost of capital, the transmission constraints, the land use, one thing that's very interesting is that actually the price of solar in the US has been increasing. Like it blew my mind because I thought, it was this magical cost curve just going down forever. But actually, you're saying otherwise. How much has it increased in the past few years?
We have seen, it was unfortunate, because I think project developers, policymakers, a lot of us were kind of betting that the cost of solar would sort of asymptotically keep falling essentially forever, right? As it had through the 2010s. And that hasn't happened in the past few years because there have been, these various bottlenecks and cost pressures that have been cropping up, which I think unfortunately, we should expect more of the more solar deployment continues. One of those cost pressures, or two I already mentioned, is finding good sites to build solar. When you start building out solar, you kind of pick the best sites, the places where you have really good sunshine, cheap available land that you're not, pissing off any neighbors when you build on. The next site you find is probably going to be a little bit more challenging. Solar has a supply curve just like any other good in the world. And we're starting to see, from a siting standpoint, we're moving up that supply curve to more expensive locations. That goes hand in hand with transmission capacity and transmission access, because that's a crucial variable when it comes to finding good places to build solar. And then in addition, the cost of capital has increased, as I mentioned. We also have seen, I think you alluded to, some of the first generation of solar projects, the performance has not been as strong as initially anticipated. O&M costs, operations and maintenance costs have been a little bit higher. The production from those projects has been a little bit lower. And so the industry moving forward is having to adjust their expectations, their pricing requirements, as they adjust their expectations for, the cost per kilowatt hour over the lifetime of a project. And so, it's not like the industry is being totally destroyed or crushed, but incrementally, yes, more costs are being layered on. And in some cases, that's going to continue the more solar we try to add in any given region.
And so if we want solar to be called a crazy cheap renewable, as you put it in the newsletter, what are some of the things that we can improve? I'd love for you to talk about, what are some of the ideas? Because there is obviously, purely from a scientific perspective, we can do progress on, the efficiency, but there's also probably some stuff we can do on manufacturing, deployment, maintenance, all of that. So what can we optimize to push further the deployment of solar panels and solar power?
So my definition of crazy cheap for renewables, by the way, is, let's say, at least 50% cheaper than we have today. That's what I would register as like a true step change in solar cost that would make up for some of the ground we've lost over the past few years of cost increases. And then at the same time, in those best parts of locations in the world to build solar, really make it this incredibly attractive primary energy resource. So what can we do? I think it's important to start by just looking at the cost structure of solar today and how it's evolved in the past decade plus. If you think back to 2010 or a little bit before, when solar really started coming down the cost curve and we really started deploying solar in large quantities, at that point, the cost of a total large-scale solar project was about half the solar panel itself, the module. And so a big reason that costs have declined so much in the past 15 years is because the cost of the module has fallen dramatically over that period, largely because of economies of scale in manufacturing, especially in China. But these, giga scale manufacturing and investment in the supply chain has been a major area for improvement historically. But today, if you look at a large scale solar project, the cost of the module is well below a third of the total cost of the capital cost, the CapEx of that project. And so there's just a lot less room to improve in terms of the bare module cost at this point. And so I think it's probably important to look elsewhere. And there's kind of two other big levers I think that we can pull. One, as you mentioned, is efficiency. And it's worth talking about solar panel efficiency because efficiency of panels has incrementally increased very gradually but steadily over this period of deployment in the past 15 years, from around 15, 16% to a little over 20% efficient today. And by that, I mean the efficiency of conversion of energy and sunlight into electricity.
And is there a ceiling on where we can get? Like, could we get to 100%? Like, is that physically possible? Because I have a hard time understanding if like 20% is very low
is it good or
is it
bad?
actually good, right?
It sounds bad because, right, 20% is not a lot. But when we're talking about crystalline silicon as a semiconductor material and basically using single junction polysilicon panels, the kind we use today, then there is a theoretical maximum efficiency, which is around 33%. So actually 20% or so is pretty high, I mean, relative to the absolute physical maximum you could achieve. And I have very little doubt that will continue to increase kind of steadily over time with just sort of incremental improvement. The question is whether you can get a step change. And the reason that efficiency is so important, if you think about the cost, like let's say we made a 10% improvement in the cost of manufacturing a solar panel. As we talked about today, if a solar panel is a third of the total cost of a project, then that's 3% of the cost of a project that we save right there. Wonderful, but nothing to write home about, and that's not going to be our crazy cheap renewables. However, if you make a 10% improvement in the efficiency of a panel, it means you need 10% less panel, 10% less wiring, 10% less structures, 10% less land. So you have a much bigger impact on the entire cost structure of the project. It's not going to be 10%, but it's going to be more like 7 or 8%. And so efficiency really is this big lever. The more you can pull it, you could even tolerate a more expensive panel if the efficiency impact is higher. And probably the most likely way to improve the efficiency of a panel is to layer on more semiconductor material, more photovoltaic material on top of silicon, which absorbs other spectra of light besides the kind of parts of the spectrum that silicon does. And these are often referred to as tandem panels. It's probably I think one of the most promising lines of research and entrepreneurial activity, which is happening, by the way, at startups as well as giant solar OEMs around the world. And largely that's focused on this material, which if you spend any time with solar nerds, you'll hear them talk about before too long. It's a material class called perovskites, which I learned about a few years ago. And perovskites are it's a big class of materials. It's not one thing. It's not like one molecule, but they're defined by a shared crystalline structure with different molecular compositions. And many of them can be used as semiconductors. And what's nice about them is they do tend to absorb photovoltaic energy at a different spectrum than silicon. So you can layer perovskites over silicon and get a more efficient panel in the process. They have some other advantages in terms of how you can manufacture and apply them to panels. They also have some real disadvantages and challenges which still exist. But that's one area that I think has game-changing potential in solar.
All right, how do we get from there to the 50% drop in cost? Because that gets us, part way through, or 50% there, maybe, I don't know. But like we still have at least another 50% to achieve. So how do we get there?
So that's where I think you have to start looking at these other elements of the cost of solar today. And if you look, today about a quarter to a third of the cost of solar is the structures. It's not the solar panels themselves in a large scale solar farm. It's these steel piles and aluminum structures that are the mounts and tracking systems that are what you're placing the solar panels on. And then maybe a quarter of the cost is the installation labor, right? And if you think about what it requires to install a large solar project over tens of thousands of acres, hundreds of megawatts, you have to have, people that are going out to the middle of nowhere, usually a hot, sunny, oftentimes dry location, and lifting heavy panels over and over, numbering in the tens of thousands throughout the day and mounting them on these structures and screwing them on. And, this is not easy work to do. And increasingly, it's hard to find people that are really willing to do that work without paying them a lot more money. And so like the installation labor is a serious component. And so that's why another vector, I think, for improving solar costs is going to have to come from some additional developments on the install and structure side. So anything that can make it cheaper to just deploy the panels. And there's a bunch of different ways you can think about doing this. One is using robotic solutions for augmenting human labor and reducing the need for human labor. So one of our portfolio companies at EIP is called Charge Robotics. They've developed this really cool system that it's sort of like a robotic manufacturing site in a shipping container like form factor that you can bring out into the field, and it attaches solar panels onto the torque tubes that are used that are eventually mounted onto the piles as part of a tracking system. So you're eliminating a significant amount of that really burdensome human labor from the process. We think like maybe 25-30% of the labor can be taken out, and there's real savings in doing that. There's also potentially new ways of deploying solar. So rather than using tracking systems, in some cases, it might make more sense to lay solar flatter close to the ground with, less steel and aluminum required for mounting. I don't know that there's going to be one single thing that's going to get you to a 50% cost improvement when it comes to solar deployment. My guess is that the best path to crazy cheap solar is going to be like 5 to 10 things that all come together in order to get you there.
Yeah, and just for context, the idea of these robots works really well for very large pieces of land where you want to deploy megawatts and megawatts of renewables. I mean, if you want to just install it on your roof, it probably is cheaper just to get someone to do it for you or just do it yourself. Because I think people sometimes get excited because I had seen a project of like a robot to do it for like private homes, and it was like it's basically installing like a couple of panels. I'm not sure that the economics works, but maybe I'm wrong.
Nah. Robotics is best for like repetitive tasks, right? That are
Exactly.
you plunk down this robotic factory in the field, and you're installing potentially hundreds of thousands of panels with it. That's where you're going to get the most savings from labor.
I just before we get to the conclusion of this episode, small remark, but we didn't talk about wind. What's your perspective on wind? Is it never going to achieve the same level as solar can do?
I see wind as a valuable primary energy resource, particularly like it is more geographically constrained than solar. That's the real challenge for wind. Is there are some parts of the world where you have really, really strong wind resources and abundant space to build wind on, and good existing transmission capacity. Perfect. Build lots of wind there. The American Midwest, like the entire middle of America, running from North Dakota all the way down through Texas, the Great Plains, has, extraordinary wind resources. It's already very cheap, and that's a great place to build lots of wind. In Europe, there's not as many good locations for land-based wind project development. Pretty much everywhere that is a good site has already been tapped, which is why Europe has been focused offshore in the past, 5 to 10 years in particular. And offshore wind is 3, 4, 5 times or more as expensive as onshore wind. As soon as you have to go offshore, like you're never getting to crazy cheap renewables, I'm sorry to say. And so, yeah, there's fewer places in the world. It's just less scalable, I think, to begin with wind. And then secondarily, I don't see as many levers when it comes to wind for making progress on cost beyond where we are today. Maybe something will arrive that is like completely comes from left field that, I certainly haven't thought of before, some new way of doing wind deployment or capturing wind power. One area that has been explored historically are these high altitude wind power generators, where you try to somehow lift and maintain a generator higher in the air, or some sort of way of capturing the wind much higher up, where the wind tends to be stronger and more consistent. But I haven't seen anything in that space that I would say like has a great chance of working at scale. There have been some pretty major projects in that world abandoned over the past 15 years as well. So yeah, like I think we should, the world should keep tapping wind. In some parts of the world, it'll be an important kind of building block, but I don't see it as being as important a resource as solar.
All right. Well, then we will only do the rating on solar, but just for people that are watching this podcast instead of listening to it, you would have seen this beautiful painting behind you, Andy, for someone that doesn't believe in wind. So
I actually started my career as an analyst focused on the wind energy sector. So wind is close to my heart, and I have great hopes for the wind industry. I just, I've come to believe I'm also a realist that solar is the bigger long-term bet.
all right. Well, solar is a fusion level bet according to the fusion like index that I've put together, which is probably very subjective. But look, we have to rate it out of 10 on 5 different criteria. Let's start with cost, affordability.
I should say, by the way, at Energy Impact Partners, we have one other bet in solar, in the next generation of solar, which unfortunately I can't talk about right now, but I hope to be invited back onto another podcast once it's something we can share more publicly that is in the perovskite space. I think that's the only thing that I can really share, which I think might have the best chance at multiple attacking multiple of those levers, pulling multiple of those levers I mentioned earlier when it comes to install cost, reducing the amount of non-active components of the system, all the mounting and such. So just want to preview that for folks as something to share later.
You know where to come for this podcast. We can cover it in a later episode. That's the point. That's the moment in time where I need to advise people to subscribe to the podcast so you don't miss out on the next episodes. Anyway, going back to the episode, the first thing is cost and affordability.
Yeah, I mean, solar is great on costs. And by definition, crazy cheap solar is crazy cheap. So if we get there, that's a 9 or a 10. We should hope.
Security and safety is probably a 10 as well. Like, there's no risk.
It's certainly safe. We didn't talk about the supply chain today and the geopolitical security issues around manufacturing in China, especially silicon wafers, for example. I'm confident, though, you could get to a point where solar is manufactured and the raw materials and supply chain are more distributed. So let's give it an 8 in terms of security and safety.
CO2 emissions.
Obviously, yeah, 10. Very strong.
Speed of deployment as well, no? Like we can deploy really quickly.
It's very quick to deploy. At the scale we're talking about, it takes some time, and the limiting factor there is not going to be solar itself. It's going to be grid capacity, which slows things down. So, I think most people think about solar as super quick to deploy, which is true for an individual project. But I think at a societal or civilizational level, especially because of the land and grid constraints, we're probably talking more like a 6 or a 7 in the scheme of things. If I think about like long-term big picture, compared to if we were to say really to scale up nuclear, for example, which we talked about in a prior episode.
Yeah, I think you had written about this queue of people that are waiting just to deploy their projects.
Yes.
That takes a long time. And the last one is scalability. It also feels like it's very strong on scalability. Solar
is practically infinite, right? On planet Earth, maybe even in space. So highly, highly scalable.
Man, I'll have to do an average, but it feels like so far that's the best grade we've ever given to any of these technologies. So
solar's amazing. It really is. Like there's a reason that so many people consider it, sort of the ideal energy resource, despite its several big and obvious drawbacks.
For sure. All right. Well, thank you so much for today, Andy. It was a great episode. For the next episode, we are diving deep underground with geologic hydrogen and geothermal everywhere. If you're building or investing in climate and enjoy this episode, please give us a follow on Apple Podcasts or Spotify, or subscribe to the newsletter at the link in the description. And obviously, you should go and read Andy's newsletter, Steel for Fuel, link also in the description. Thank you so much, Andy.
Thanks, Hugo.